Um, and hopefully all technology will work today. But I'm going to welcome everybody to this webinar. This is an Envirothon webinar that is being put on by myself as part of the Envirothon, I guess, committee now for this year, which has the special topic of climate change. So my name is Susan Quincy. I work for the DEEP, and I work out of the Kellogg Environmental Center, which is located in Derby. And we are part of the Education Outreach Office of the DEEP. So we have educational resources for schools K through 12, as well as university level, to incorporate topics of science and environmental conservation and resource preservation into curriculum for science, mathematics, and language arts. So you can use us as a resource at any time, and my information and email will be at the end of the program today. So if you have any questions, you can certainly add your questions to the chat. And if you have any questions afterwards, you can also email me at my work address, which is susan.quincy@ct.gov. And so we will be getting started, and I'll be starting with my PowerPoint and then going into what is known as the En-ROADS Climate Action Simulator. So we are going to be focusing a lot on that. And if at any point you have any questions during the presentation, you can certainly feel free to unmute yourself and ask them directly, or if you'd like to type them into the chat, I will check the chat at the end and see if there's anything that needs answering, and we can have those discussions later. So by all means, you can certainly ask your questions whenever you feel you need to. And we are going to just go ahead and start. So hopefully you're seeing my presentation slides here. And this is a program that I do for schools. So beyond Envirothon, if you're looking for a presentation for students or green clubs and things like that, we have the program that's called 10 Minutes to Save the Planet, which gives students 10 minutes to talk about different activities and actions that can address climate change. And that's our topic that we're going to be looking at today, and starting with the discussion about climate change and what you might be expecting to have your students prepare for when they're doing their presentation this year at the event. So this material that we're going to be sharing with you, En-ROADS, is all designed and supported by the group called Climate Interactive. And they grew out of MIT Management, and MIT developed the Climate Simulator, which is an online tool that people can use to see what types of outcomes would happen if we do combined actions on climate to address carbon dioxide. So that is the model that we're going to be looking at, and it's easily used, and it's all free and available online for students and teachers. So it's easily accessible. When you go on to En-ROADS, you'll see that it has this as their tool page. And so this is the simulator itself. And it's looking at what are the possible ways we can address climate and climate issues. And these are the different categories that you can address. You could go through addressing your energy supply, looking at transportations, buildings, the growth index, carbon removals, and then land use decisions, all of which have different ways in which we can bring down carbon dioxide building up in our atmosphere. So when we're starting this year's presentation, we'll be looking at and asking students to start to frame the subject itself and look at how do we address climate actions and global warming. So these are all uses of terms, and that's where it begins, is to try and have students understand the terminology, and we'll be looking to see how students use that terminology and if it's used correctly. The main thing that myself in DEEP and as an environmental educator is looking for ways in which people can best communicate science and understanding of science. So this is a real big important step in preparing a presentation, and there are some resources. One of the webinars that will be coming up for the climate topic and is toward the end, is how do you say things? And what are some of those things that have been studied now and presented and developed to help people understand the topics and the information around climate? So we're going to start out with reviewing some of the very basics and then looking at what is at stake if we don't, or if we do, take climate action. So one of the resources that you can utilize when talking about climate and finding out ways to frame your information is information that was developed with the National Network for Oceans and Climate Change Interpretation. That's often referred to as NOCI. And the phrase rampant CO2 adds to heat trapping blanket is an illustration of how they've incorporated some of that terminology into discussion. So it's the rampant CO2 levels, the overuse of fossil fuels that is producing CO2 into the atmosphere through human activity that is increasing our heat trapping blanket. And heat trapping blanket is one of those metaphors that we are in environmental education utilizing, because that's an easy way in which people can see and understand the purpose of our atmosphere. We also have visuals that people have in their mind, and obviously glaciers are one of those visuals. But the things happening here in Connecticut are sometimes more subtle in the changes, and it's slower than what we see when we compare the melting of glaciers. So we also want people to understand what's happening in their own backyard, because that's what they're technically feeling as part of the change. So the basic understanding of what's happening with global warming is that the sun's heat comes down and is trapped in the atmosphere. Now, if we didn't have an atmosphere, our temperature would be 0 degrees Celsius. So our atmosphere acts as a greenhouse. This is why we will use the greenhouse gas terminology. We'll sometimes use a greenhouse metaphor, but the use of the heat trapping blanket really illustrates how we are padding our atmosphere with more carbon dioxide and other carbon-based gases. So the basic level of our atmosphere is meant to trap some heat so that our surface can stay warm. It also keeps water in our atmosphere and close to our surface in the troposphere so that we have the water cycle. That's making our planet one of those unique planets in the solar system and supporting our life. So we have oxygen, we have water, we have cycles that have all been going on, and utilizing the dynamics of what the atmosphere does, allows some heat and ultraviolet radiation to go back into the space, while a volume of heat is meant to stay trapped here so that life can exist on Earth. And over time, there has been changes in the atmosphere for the density of how much carbon dioxide is there. However, when we're looking at recent history of what is known as the human effect, we're looking at a drastic change in that temperature. And that is what's changing the systems here. And that's referred to as global warming. So over time, we have seen CO2 increase. And how that's been researched is through a variety of methods, using deep sea core sediments, using mostly polar ice cores, where they're examining the different ages and levels of gases in the atmosphere as bubbles that are trapped in the ice core. And there's a picture of a pattern, rather, that is being seen from 800,000 years ago to present day. And then all of a sudden, we start to see a spike. So we know that carbon dioxide in the atmosphere was generally the highest levels was around 300. I think the highest level recorded was about 320 at one time, but around 300 is the normal highs. Okay? But then suddenly around 1950, it starts to go higher and higher and higher. And that spike correlated with trackings of surface temperature. So there's a variety of records that one can go back to, looking at observation of weather, observation of temperature, and looking at, especially since 1880 to present day, a steady increase that has been seen of the highs and lows. And those start to track with that same time in which we start to look at our carbon dioxide sources. And the emissions start to spike around the 1880s. That's when the Industrial Revolution was in force here in North America. And that was the use of coal was very high. Later on in the 1900s, oil's discovered, oil starts to grow in volume of use, and then natural gas peaks off. And then we have the area of others, which is that little gray line. And others is made up of the group of materials made from concrete and off-gassing, so the gas flares. So others starts to climb the more we're using natural gas. And then the land use changes continues to be part of that. And the land use changes is part of what would be known as a human aspect, but also part of a normal cycling of things. So how plants are and land is being modified all adds to carbon dioxide. So the biggest things that really started is we started to see a high volume of carbon dioxide emissions, all related to fossil fuel use and human industrial activities. And that's when we start to look closer. In the 70s, we're looking at air quality, and we're breaking down those specific things that are starting to carry carbon into the air. And we have methane levels, we have carbon dioxide itself, we have nitrous oxides, we have fluorinated gases, all coming, especially fluorinated gases, and increasing from human activity and the direct burning of fossil fuels and adding of industrial process. So we have a lot of data that has been researched and broken down over time, so that when we're putting together those models, they're looking at projecting for the future. And what has been designed and has been developed is the projection that on a global basis, if we do business as usual, so we do no further cuts of carbon emissions, that by the year 2100, we would be seeing an increase of 3.6 degrees Celsius, or about 6.5 degrees Fahrenheit. So that increase in temperature is going to result in climate change. Now, we've had an increase in temperature of a global warming of just about 1 degree at this point. And that's the global aspect. So as the atmosphere is being packed with more carbon dioxide, more heat is trapped there. Connecticut has seen on average a 2.2 degree increase of annual temperature. We actually have seen a higher increase in winter months than in our summer months, which is very significant when we're looking at natural patterns and impacts that we're seeing and changes here in Connecticut, all related to that warming aspect of our atmosphere. So global warming creates climate change. And climate change is identified by a variety of indices, such as sea level rise, phenology changes, different ways in which insects are going to be able to move around, changing of sea temperatures, things like that. So all of those aspects that we look at as outcomes of climate change are illustrating climate change because we have this warming aspect. So our goal is to not have 3.6 degrees Celsius, definitely not to have that, and to try and maintain a temperature rise globally of 1.5 degrees Celsius. So that's the IPCC, the Panel on Climate Change, general goal in which the UN has adopted to take on a target for countries to work toward. So we are going to start to look at what would happen if those things didn't go into place, if we didn't take steps to limit and reduce carbon emissions, but also remove carbon from the atmosphere as well. So we all have heard about some of these changes, and we know we are experiencing extreme weather. Connecticut is now going to have frequent small-term droughts that in different parts of the world, you're going to see a more intense change than you might in other areas. So in the Arctic, permafrost melting is a very large concern. The acidification of oceans, or the pH changes in the ocean, area is another large concern. So these are all of things that are going to be happening on a wide basis. And when we're looking at Connecticut, we can see some of those changes also. So these are some of the resources that are listed on the En-ROADS, or not, excuse me, on the Envirothon's website to help students find information about what's happening here in Connecticut. This is made a map from Surging Seas, which is a website you can use. But you can also get these maps projected from Circa, which is out of Yukon. And this shows if the map on the left is if we don't do any pollution checks at from this point forward, that this is the area of New Haven that will be underwater. So the blue inland areas is the flooded zone. If we do extreme carbon cuts, which will fall into what is known as our zero carbon, net zero carbon, we will still see some sea level rise experienced in New Haven. So those are the projected blue areas of flooding, much less than if we didn't do anything at all. And part of the reason why we would still see that is because we are expecting in Connecticut to see about 20 more inches of sea level rise by 2050. So that's a known standard at which will happen because of the amount of carbon that is currently in the atmosphere and the amount of activity and time it takes for things to catch up. So we will continue to see some sea level rise, and these are the areas. So looking at that map, we know those areas will have to have some sort of climate change adaptation. When we're doing an activity that's referred to as an adaptation, that means you're making changes to behaviors that you are going to be doing to modify impacts or to reduce the impacts of what you know is going to happen. So we're adapting to changes and impacts that we are seeing in Connecticut. When we do something that's known as a mitigation action, that's when we are actually reducing carbon levels being put into the air, or we're going to be taking carbon out of the air. So those are mitigation steps that directly affect emissions. One of the resources that has been provided that we hope that your students will start out with, and this is something for a review to begin their process of preparing for Envirothon, is Connecticut, Our Changing Climate. It is available as a PDF on the DEP portal, and I will add that to the chat, but it is also identified as a resource on the Envirothon website itself as well. This is a very small booklet. It's about 30 some odd pages long, and it highlights the specifics of what is being seen in Connecticut when we're talking about the different ways that we're being impacted. So it talks about changes in fish species. So we're seeing more warm climate fish than cold water fish. When they're doing fish trawls, we are seeing a higher rate of insects. There's a higher rate of disease and human health issues, and also talks about some of the resources that we can point to see how different communities and towns are reacting to these changes that are being predicted and actually being seen. So here in Connecticut, this is what's at risk, is instead of polar bears, our polar bear is really the salt marsh sparrow, which is right there in the center. And it is expected to be extinct in 2050 or sometimes after that, only because we are looking at so much sea level rise that the habitat it needs is going to be flooded, and it cannot adapt on its own unless we give it some sort of areas to go to, we increase, and we retreat back to allow more salt marshes to come up. That's the only place it's going to be nesting. So that is our polar bear. We also are seeing some changes in other wildlife. We definitely have lost lobster as an economic resource for fishing. The moose is in peril, basically, in the southern region of its areas that it's normally populated, which is mostly in New Hampshire. So we will occasionally see moose here, but the moose is really something out of a New Hampshire issue, because of the increase of ticks, and winter ticks are not being knocked back. So it doesn't just impact humans, it also impacts the natural chains for systems on land and in water. We're seeing a higher air quality index problems. We're seeing higher heat days. So all of this is causing us to either have to change our behaviors or put in stop gaps. One of the things that is highest risk in Connecticut is our culture and traditions around winter. Because winter is now warmer by on average 4 degrees, we will still have cold, but we don't have a lot of cold, and we have cold weather, but not snow. We get most of our precipitation now in the winter as rain. So we have a higher increase in freezing rain as well as rain itself, which changes a lot of ways in which water is able to recharge. It changes our recreational activities, and it impacts the quality of different aquatic systems. So there's a lot of things that can happen with just a small number. And that's the important part, is looking at those small numbers and seeing how big of an impact that is. So it sounds like all doom and gloom, and we don't want to leave it at doom and gloom, because there will be some opportunities. And that's one of the aspects that students might find as well. What are some of these opportunities for addressing climate change, and how do we actually celebrate the solutions? So that's where we use what is the Climate Action Simulator. This allows students to look at some of the things that they're hearing about, they might have read about, and they certainly would be starting to discuss when they're preparing their presentations as to what would they do to adapt to climate change. So what are some of the steps? What are some of the projects that they would work to support, or they would start to develop? So when we're going to go into the En-ROADS board, these levers are all connected to a climate action. That is a policy statement by not only Connecticut, but also the United States on whole, and then on the whole global community. So we can look at all these different sectors, and in all of these sectors, there are actions that have been suggested for our state and for the world to address the reduction of carbon. Putting those actions into the simulator, students are able to see the outcome of their, let's see, I'm going to stop this share, the outcome of their suggestions and their solutions. So at this point, I am going to end this show, hopefully. It won't shut off. I will have to find it. There we go. And we'll go right to that simulator. So when you take your students to the simulator, they can play with this. It's a fascinating thing. And the key aspect of this is it is not just one right way to use it. So you'll go to En-ROADS. This is their main page. It's known as Climate Interactive. You can Google En-ROADS. You could do Climate Interactive. It'll take you to this spot. And then you're just going to click on Explore the Simulator. And this is what the simulator looks like. So at this point, we're going to do a quick rendition of 10 minutes to save the planet. It might be a little longer, but I'm going to ask you to open up your mics and go ahead and tell me some of a suggestion for addressing climate change. And I have to apologize if you're seeing me fight the cat, but we're fighting the cat too. So who, you're not seeing the screen? Okay. Let's go back to this. There you go. Are you seeing the screen now? Okay, so you can type an idea in the chat, or you can just go ahead and say it.
I would say try to increase the renewables.
Okay, so what you'd be doing then, if students suggested, let's do more renewable energy source. So that would be like putting in wind, putting in solar panels. So we're going to incentivize it. And so by moving that lever, you would then go up to this looping arrows, and you're able to see what that action does by just increasing renewable energy, which does not have a big turnout, does it?
Not much.
Not much. Okay, but if we're looking at the graph that shows us what the greenhouse gas emissions will do, it shows that a slight reduction in temperature expectation will take place. If we look at the fuel source, you see some reduction of fuels that are fossil fuels as that green band starts to widen. So what else?
What about the electrification of transportation?
Okay, so if we go to transportation, and we are going to make that a highly incentivized, and if you want to be the student, we'll max it out. So if all transportation is electrified, let's look at our graph reactions here. 3.3 degrees now. A huge demand in energy from renewables. There is a reduction in the others, but still not there because our goal, 1.5 degrees.
Deforestation.
What about it? What do you want to do with deforestation?
Yep.
Do you want reducing it?
Reducing it, yes.
Okay, so we're going to pull that over. We're going to highly reduce it. And the interesting thing, when we do a land use action, we may address, you see a slight reduction in the temperature, but there is no movement on the energy source side. That's because you're not addressing what you're using as your source for energy for that action.
Oh,
So I'm just going to say, hand in hand with reducing deforestation, we are going to increase afforestation, which is the planting of trees. So that is under the category of carbon removal, not land and industry emissions, because that is specifically addressing the absorption of carbon that's already in the air, as well as what you might be putting in. So if we limit deforestation and we massively increase afforestation, we are only going to see a net change to 3.2 degrees Celsius rise. So it's helping, but we're not getting to that 1.5 degree. Now, one of the things you can look at with your students is there is also contained in here a variety of graphs that you can turn and look at. So you may not be doing what you thought you wanted with your greenhouse gas emissions, but let's see if by that afforestation, we now see we see a new sector coming on, which is under the land use. So now with our greenhouse gas by gas emission, we're seeing what's the impact that we're doing on methane or on carbon dioxide. So if a goal is to address climate change, but also to address methane, you would then start to target those activities that reduce methane as your goal. If you're looking at absorbing carbon dioxide, which is taking that excess, because we're far over the normal limits. So we know we have to not just stop putting more up there, we also have to take it out. So we have to do something. And that means that we will then start addressing some of that excess emissions. So you can change these to be any sort of these types of graphs you'd like. So we're going to go back to our temperature change goal though, because that's our biggie.
I think then we have to reduce the coal and the oil or the natural gas.
Okay, so we're going to then, that would be taxing coal. So we're going to highly tax coal, and we're going to highly tax oil. And now we've broken the two mark.
Ooh.
Yeah, whew, it's almost there. So that's when you can see, a little change in temperature, but you see the energy sources shifting. So that's behavioral change and reacting to the fact that you've already increased renewables and you're identifying the coal and oil as your problem children in the fossil fuel areas. But we're not there, so we have to do other stuff. We have just 3 minutes left to save this planet. We got to get it down. Is it possible?
How about increasing the price of carbon?
Okay, and that's a big lever. So now we've already done these two big carbon ones, but if we do a general carbon tax, so we're doing a very high carbon tax. That brings the temperature down because it's reacting to that push to actually limit coal drops out and oil drops very low. And in general, all energy that we're using in exajoules per year is reduced because of the volume of which we're taxing that carbon. So when we say something like the carbon tax, what does that mean that we're actually doing? Which means these are when you would want to go in and explore the ... dots. So at any time, students can go in and see exactly what that means. So if you're doing a carbon tax that's very high, that would be $131 per ton of CO2 emitted. So industry would be responsible for that, as well as individuals for carbon production. So that would be a tax on what type of car you might be driving, because that's how much it would be generating carbon dioxide if it was still using fossil fuels. If it's an electric vehicle, it would not have that carbon tax. So you have those types of information. You also can see, if you go into the I, it brings in information and examples on the background of that for students. So this sets up some of that research to understanding why some of these actions are being pushed at certain times. So the bigger switch to electrification is a step to starting to bring down carbon source fuels. So we're starting to see some of those changes. If we go down here, it also has what is known as a co-benefit and equity considerations, because some of these steps or ideas into reducing carbon can put other communities at a disadvantage. One of the things that gets addressed when we're doing that is we're thinking, again, this is a global action. So this is not just what Connecticut does, but you're saying if on a world scale, carbon is priced at this, that means that coal, which is the cheapest fuel source for many of those small emerging countries, is suddenly out of reach for them. So they do not have an affordable energy source, which is why you don't take coal completely out of the picture all at once, and that you have to give time for third world countries to build infrastructure that would allow alternative fuels to be used. So they're going to have to first get to carbon, and then they'll get to renewables and low carbon emissions. So there's strategy to some of these steps. And that's why the simulator is really good at putting those in and putting them for outcomes, because they run all the algorithms at once. So let's do a couple other steps here to see if we can get to at least the 2-degree temperature change. If we can do 2 degrees by 2050, we got a shot at doing 1.5 by 2100.
So Sue, let me ask you one thing. What exactly is the new zero carbon energy supply bar?
That is the unknown technology. That would be fusions, hydrofuel, an unknown source.
Gotcha.
And so if we have a breakthrough, see, we got a peach line now, we got the little orange line that comes up. If there is a breakthrough and it starts in 2040, that's the other thing is you can adjust. So students go in, they can change these numbers, their breakthrough years,
Hmm.
when it starts and things like that. So they can make some of the adjustments.
Okay.
So if that happens, we come down another degree, we now have another fuel source to pull from, but it's zero carbon.
Right.
Mhm. One of the interesting things, I know everybody is, inflation is a problem, but economic growth, if we suddenly ramp up production of things, look what happens. We're going to go the other way. So economic growth, stop its little simulation here. If it's slow, that actually reduces carbon emissions.
Hmm.
So that's the other push and pull of life that happens. Now, we electrified only transportation. Nobody's addressed buildings and industry.
Well, Sue, what if what if we electrify industry?
Okay, so we can do that. We can incentive electrification use. At this point, you don't see an impact too much because we've already electrified all this. We've put this emphasis on renewables and things. If we make our buildings efficient, which means you get better window treatments, you get better appliances, you're using less energy because everything's more energy efficient, even though it's electrical. So efficiency is one of the first steps that is taken. So we can see we've drastically reduced this. So let's change one of these graphs here and show what happens to the cost of energy. In all of those activities that we've taken, you see energy spike. The cost that you're going to pay for energy, whether it's definitely going to be electric, but whether the source is coal, oil, or renewable, spiked very quickly because it could. It's basically the outcome. And then the cost drops. So that by 2100, your cost of electricity is below the average of what it was when we started 80 years prior. And you can break that down into the cost for individuals. And this is where the shift in your energy source relates to lower cost of energy. So when we did all this in the beginning, the renewable energy costs, if you were getting energy or electric from wind, solar, geothermal, all of the renewable resources, it went down. The cost per gigajoule of that or kilowatt went down. And you saw a spike in the cost of oil. You see a spike in the cost of coal, which would be that equity issue. And you see a spike in the cost of bioenergy using the organics as a fuel source. So those are things that are discussed. And that's the benefit of some of these decisions is once you start to put in, we're seeing a projection at today's algorithm rates of 3 cents per kilowatt when using renewable energy. So this gives some real world outcomes for students that they can start to see. They can then change some of their graphs. Let's see, we're going to move the lever for technology of carbon removal Or we can use the methane reduction. Which one shall we pull as our last lever?
Let's do methane and other gases.
Okay, so that means we're going to be trapping methane. We are going to alter agricultural process. Let's highly reduce it. There we go. Whew, we're under 2 degrees. Okay, but
Wow.
these are all the steps that have to go into addressing that carbon goal. And what students can do is they can project their first plan going on the scenario of this is what we think should happen. And they can take this, they can save it, share the scenario so that this whole vision here, the view is saved as a JPEG. And that can become part of their presentation so that they're showing this is the climate action model, that if all of these steps are taken, we will be close to, not at, but close to our goal of 1.5 degrees Celsius temperature rise. Okay, and then they could identify specific programs or projects that are being taken here in Connecticut to do one of these levers. So if they were doing a presentation and did a scenario as this, they could identify the use of renewable energy with the wind farm that is being built off the coast of Connecticut and Rhode Island. So will be the largest wind farm in the Atlantic of North America. So is one of those zero carbon goals for Connecticut. They could talk about the energy efficiency program that is currently in Connecticut and how to make that more effective or accessible for low income people. So more lower income people are utilizing those benefits and those incentive programs. Looking at different ways in which buildings are used or how buildings are built, how green spaces are planned. Things like that all become now part of addressing carbon and also addressing clean air, clean water, and natural resource conservation in land. So this is the En-ROADS simulator. It gets people talking, and it also illustrates the primary thing that there is no one action to address carbon reductions and global warming, that it's going to be a collection of actions, because you can say we're all going solar, but if you're living in the Arctic areas, there's not a lot of solar power to pull from for most of the year. So that's not a step that works for everything, as does nuclear power or the use of bioenergy and things like that. So there's a variety of ways that this could be laid out in order to reach the goal with different aspects. And that's what we're going to be asking your students to do, is to come up with a plan. What are some of these actions and how do they relate to Connecticut? So at that, I am going to stop presentation here because I've done a lot of talking, and we'll see if anybody has any questions or any thoughts that they'd like to share.
So I've just got a quick question. We didn't really play around with the nuclear energy bar, but if we were to increase that, I'm not very I just don't really know what's done with the waste produced by nuclear energy. So what would sort of what would we be looking at for that? If we were to increase it, what would be done with the waste?
Well, that's the thing. That's the problem with nuclear energy. The waste handling is always the question, because that's a long-term hazardous product.
Yep.
So I moved the bar here, and with all those other scenarios, it had no effect by going nuclear. So in your previous scenario, see, it just did that.
Yeah.
So if you're saying if you were going to take the stance that you do not want to increase nuclear power, you could come up with a plan that reaches the goal without using nuclear as an option.
Hmm.
And now you have a justification, because there is always that question, what do we do with the waste?
Right.
And now that, the other question that why nuclear plants are being upgraded or decommissioned in some cases because of extreme weather. They have to be located on a body of water, a large body of water for its capabilities. And so it makes it very open to damage from large storms, as we saw in Japan with the nuclear reactors there. So if extreme weather is building and hurricanes continue to be more intense when they come, then you have to rethink the use of nuclear power.
Right. Gotcha.
Also, nuclear power, not a carbon, it doesn't emit carbon dioxide, but in order to build it, it uses incredible amounts of cement, which is one of those other aspects that adds to carbon emissions.
Hmm. Gotcha. Thank you.
Mhm. Okay, I'm going to reset this back to the original. And then you could see if we did nuclear, that's the effect on its own if you started with nuclear. So. Okay. Any other questions? Especially, if you're going to be coaching students, how would you introduce this to them and let them utilize that machine? Oh, one thing I didn't mention, and I should, is that to use the En-ROADS simulator, you have to have a computer laptop or a monitor, or it also works on Macs, but it has to be a computer. It does not work on phones and tablets. It will work on, I think, a Chromebook, but definitely has to be a computer. And that's because the volume of math calculations that it runs.
Susan, will population control do anything with the graph? I know we didn't look at it.
Well, we'll take a look at population. They all do something. So if we if we grow population, it makes it go up. If we lowest growth population, it goes down slightly. And that's when you want to pull in those. That means it'll be 8.8 billion people in the year 2001. And interesting enough, next month, the world will be at 8 billion. So the 8 billionth baby will be born next month, and we'll then be at an 8 billion planet. Also, by the end of the year, India will surpass China in population.
Yeah, probably with that China's only child policy, but that was recently lifted. So who knows what will happen with that?
And that didn't turn out too great for them either. Now, if you're looking for more information on En-ROADS, they have tutorials online that talk about how the simulator runs and different steps and different insights that you can also use for it. There is a game that you can use with your class if you're going to use this on a larger scale than just your Envirothon team, but where they simulate the UN summit, taking on different teams aspects, so they can be different stakeholder groups, or if they run these C-ROADS, they can become different countries, and they can go to the UN representing the European nations or the small pack nations, which are third world nations, or US, China, things like that. And it breaks it down to their individual actions. So I hope you can use this with your students. They will be asked to utilize it in some of their discussions for the actual scenario. So if you have any questions in accessing it, or students have any questions when they're utilizing it to come up with their plans, you can always ask.
Susan, I just want to say thank you so much for doing this for all of us in Envirothon steering committee people sitting here, and you brought it up at our steering committee meeting last month, but this is really, it's pretty intense when we think about what our children have to start doing and what we have to teach our young people to do, because this is past what we're going to do in the rest of our lifetime.
And
our
that is the
lifetimes. Yeah,
indigenous
yeah.
communities connection, because they think 7 generations ahead, whereas our culture is locked on our immediate want and need now.
So thank you for this. I appreciate it.
You're welcome. Okay, well, I thank you all for coming. And if you have any questions, do please just ask them or type them out. You can send them to me afterwards. And this will be posted on the Envirothon resources and webpage following the presentation. Give it a day or 3, because it takes time. But all righty, thank you.